Hey there, this is James Darknell from the Foundry. Welcome to Modo In Depth. In each episode, I'm going to choose one specific function of Modo and go into detail about every setting, sort of like video documentation. In this episode, I'm going to cover the image map layer. I'm going to venture a guess this is the most popular shader tree layer in terms of overall usage, mostly because this is the only way to get photographs and other types of bitmaps onto your surface. So every time you apply or add an image map or a procedural texture, you get a texture locator. So this is going to be a two-part series. In the first part, I'm going to cover the image map, and in the second part, I'm going to cover the texture locator, because they really sort of work hand in hand with each other, and it's really best to get the most out of them to understand all of the settings of each one. So let's jump into it. So if you've worked with the shader tree at all in Modo, you're going to know how to add an image map into here. And if you don't, I'm going to show you right now. So we're just going to go into Add Layer, and we're going to go under Image Map. And under Image Map gets you a bunch of options here. So you have Load Image, and what that does is it opens up a file browser where you can locate the image map on your hard drive and click it and then load that in. There's also an option to load a layered image. And what this mostly does, or what this specifically does, is you can take a PSD file with multiple layers in it, and what this does is it loads all of the various layers in one go, and then it'll treat them as various image maps individually. So each layer within the PSD will be its own image map, which you can then apply singly. Then you also have load sequence, and this is for video footage that you've converted to image sequences that you want to apply to a surface. And the only difference between this and loading a regular image is it gets you an additional sub-tab in the Properties panel that lets you control the start frame and end frames and some other settings specific to sequences. And then lastly, we have the load UDIMs. And a UDIM is a specific way of UV mapping that allows you to apply multiple images to a single object just by using different spaces within the UV space. And this isn't about UDIM, so I'm not going to go into any detail about that. And all of these other settings under here allow you to create new images. You can create them and paint them or bake to them or whatever without having to have a source bitmap on your hard drive to begin with. So this is just basically a duplicate of these options up here, but it's letting you create them from scratch. And then the one we're going to be using is the clip browser here. Because I've already loaded this in. So any images that you load into Modo, whether they're in use or not, once you've loaded them, become part of the clip browser, and they'll be viewable in here. So I'm just going to click on that, and then that loads that onto my surface. So like you can see, we get the image layer, and then you always see this texture locator layer underneath this. And this is actually a separate item in here. So you have the image map itself and the texture locator, and they're always going to be associated with each other because you can't really have a texture image in your scene without some way to assign it to your surface using the settings of the texture locator. Like I said, I'm going to be covering the texture layer options here of the image itself. So obviously first half we have the enable option here, and this is the same as this sort of little eyeball setting where you can toggle the texture whether it's on or off, and when it's disabled it doesn't get evaluated during render time. And then we have the invert option, and this reverses the RGB values, and it doesn't show up in the default viewport here. And I think just for the rest of these, to make this more obvious, I'm just going to open up a preview window and we're going to look at this in preview. This will be more clear what the settings are going to be doing during a render. So by clicking on the invert, you can see the blacks turn white and the color values all invert, so it's sort of like a film negative in a way. And this is useful for black and white procedural images mostly. So if you have a noise texture or you're using checkerboard and you want to invert it really quickly, the invert is really useful for that. I can't think of a time that I've ever actually used it on a bitmap texture unless it was a black and white image that I was applying to specular mount or something like that. Next up, we have the blend modes. And the blend modes are, if you're familiar with any sort of image map editors such as Photoshop, what have you, these allow you to blend multiple layers with with underlying layers. So in this one, we have the base material, and the base material is just sort of this white color. And if we make any adjustments to that, you're not going to see it because the image map layer set to diffuse color is overriding that diffuse color value that I have down here. But if I were to change this blend mode to say something like add, now if I go into the base material and I change this color to something else, now you're going to see how those are affecting each other. So the base material sort of being like an uber set of layers. All of these different things sort of represent their own individual layer. So the blend modes allow you to blend multiple layers. We can go back to normal here. It's more obvious if you're using multiple texture layers or multiple image maps. So I'm just going to load in a quick image here again. Load image on that. Put in this chrysanthemum layer. And I think this will make it real obvious that when we use the add, that it's going to be doing an add calculation between the lower layer, the koala, and the upper layer. So this is just the blend mode names are named after the arithmetic that is applied to the actual RGB values. So we have subtract, difference, normal, multiply, divide, soft light. A lot of these are kind of esoteric and don't get used very often. I will say that 90% of the time, maybe 99% of the time, the ones that I mainly use, normal excluded, would be the add. And what the add does is if you have, say, a black and white image, is the black essentially disappears and becomes transparent, and only the white parts of that will show through. And then I also use the multiply, which is the inverse of that, where all the white disappears and only the dark areas of the images show through. And then the last one that I use a lot is overlay, which is sort of a mix between the multiply and the add, where that's where 50% gray disappears in your image, and everything that tends towards white will lighten the underlying color, and everything from 50% gray toward black will darken the underlying color. And then we also added this normal map blending. So if you have a couple of normal maps that you want to blend together, we also have a normal map blending mode here, and then you can control the strength of that blending by using the opacity. So if I put this back to normal, the opacity is just another way of controlling how multiple layers blend together. So as you can see, as I change that opacity, those two layers are starting to show through. So if I go to 0 opacity, that makes it 100% transparent. So opacity is just the inverse of transparency. Now the locator and projection type, well actually the projection type and projection axis, these are settings actually of the texture locator, and in Modo 10 we added them into the image map layer here just for convenience to make it easier to select them, so you can select your UV maps and what have you more easily. And the texture locator allows you to specifically choose which texture locator is going to be controlling this layer. It's very, very rare that you would ever change the texture locator other than the one that's created by default when you add your image. But if you ever come across an instance where you need to do that, this is what this setting does right here. Now here under the image map setting, these are all of our image map specific settings. So obviously you can select a different image here. So we could choose the koala here and change the image this is while retaining the settings of our texture locator. And maybe this is useful if you've imported a layered PSD image and you've specified the wrong layer. For some reason, you can just go in and easily choose which actual image represents this particular layer. Now, the next settings here are the anti-aliasing settings. And the anti-aliasing is an effect that's applied to the image during render time. And honestly, I disable the anti-aliasing in all of my images. Now, the reasons when you would want to use anti-aliasing is when your bitmaps are a lower resolution than the target rendering resolution. So let's say, for instance, you are rendering game assets and the game texture for your whatever it is you're rendering is low resolution and you can see jaggies in the rendering. You can turn on anti-aliasing for the texture itself and it will smooth out some of that jaggedness of those textures and make them appear better. But anytime your textures are higher resolution than the target render resolution that they're going to appear in the frame, for me, I'm often 2 to 3 times higher resolution than what the final rendered frame is. I find that anti-aliasing just softens up my textures, and I don't like that look personally, so I disable the anti-aliasing on that. And there is a preference setting under System Preferences, and we go to the Images and Painting, where you can disable image anti-aliasing by default. So I like to disable that so that I don't have to turn it off individually in each image. Now, in the instances where you do have anti-aliasing on your images turned on, the anti-aliasing strength basically controls how strong that anti-aliasing is applied to it. And if you're using it, you probably want it to be set at 100%. And then the minimum spot is controlled by the number of samples that are taken into account for anti-aliasing for pixels, and that's the rendered pixel, not an actual pixel in the image. And this is kind of useful for blurring out images. So there might be cases where you have a sharp image that you're using in one case and you want to kind of soften it for another use. So you can actually enable anti-aliasing for the image, and then you can increase the spot size. So if I do something like a larger spot size on that, you can see how it starts to blur out the image like that. So that's one of the uses, I think, for anti-aliasing. And then lastly, you have the texture filtering mode, and this is how the texture filtering is essentially filtered as the pixels from the image are sampled during the rendering process. And I set that to bicubic because that's the highest quality setting out of all of them. You have bilinear and then nearest neighbor. So bilinear will blur the image, but it only blurs it horizontally, and then the bicubic sort of blurring is not the right word, but the sampling is only horizontal, and then the sampling is horizontal and vertical for the bicubic, and then the nearest neighbor is basically doesn't take nearby pixels into consideration. So if you're familiar with Photoshop at all and you scaled images, you can use the nearest neighbor and the bicubic options inside of there, and it's really obvious when you start scaling images what those different settings do to the image. So if you have an image editor, you might try experimenting with these different settings, do extreme scale up and extreme scales down, change the texture filtering method to get sort of an idea of the differences between those. But if you want the highest quality, I just set that to bicubic on there for the texture filtering. Now, these low values and high values you won't often use for image maps. And I use the low and high values. So if I'm using a specular and I want to lower the lowest specular value, or I have an HDR image and I want to sort of multiply what the brightest part of the image is, these are sort of ways to control the mapping from the darkest to the brightest. And, obviously the black would be the 0 and white would be 100%. But what if there was instances where you had an image that you wanted to be, really bright or something like that? Then you could boost its high value to 200, and then everything in between from 0. So basically what was at 50% then becomes 100%. So it's just a way of remapping the pixels. And this is often something that you will use with displacements, where you will set 100% here, then the gray shade will be no displacement at all, and then you'll set this to negative 100, and then everything that's 50% gray toward black will push inwards on the surface. But, this isn't specifically just for displacements or bump maps or that sort of stuff, but I use it mostly for bump maps and displacement, so they can kind of control where in that range I want a specific layer to affect the displacement. So sometimes I might set a low value to 50% and a high value to 100, and then I'll change the opacity or the blending mode of that, so that way I can control multiple layers working together, and what ranges of those shades end up in the final result, the calculated result. So maybe I can give you a quick example of that. So maybe I'll just throw a noise texture on here, which will have a similar setting. So if I set this to displacement here really quick, and then I give this a longer displacement, say something like 100 millimeters. And then I'm going to turn off these real quick just so it's obvious to see what's going on here. So say you have these values. Since I'm using this as a displacement, this is going to be using the value 1 and the value 2. So say this is the same thing as the low and the high. So this is at 0 and value 2 is at 100. So if I were to take this and go to negative 100, you're going to see I'm going to get double my displacement value, because now the 50% part is pushing inward. 50% to black is pushing inward, and the 50% to white is pushing outward. So essentially that's what the low and high values are doing. And it also works sort of as a multiplier if you have a high dynamic range image. Even though your values go beyond the traditional low dynamic range 100%, say your brightest point in an HDR image is 500%. If you set a high value to 200%, you're basically multiplying that highest value by 200%, and then that becomes 1,000%. So if you're trying to brighten up, say you have a dim light source in an HDR and you just want to boost the brightness level of that, you can use the high value as a multiplier for that HDR image. So the low and high value are really useful settings. You just don't end up using them a whole lot when you're just using straight up bitmap images for, say, diffuse color. Now the next settings allow you to invert individual channels of the image. So say you have this one, we can invert the red, which just inverts the individual red channel of that. Obviously the same thing for the green channel and the blue channel. And those by themselves aren't specifically very useful. But when you're doing game assets and you've imported, say, a Unity asset, and you've embedded different effects within the different channels. So in Unity, you can say put metallic in the red channel, and you can put the specular amount in the green channel, and then you can put the reflectivity or whatever the next setting is in the blue channel. Sometimes if you've set those up wrong or put them in there, it's real easy to just invert the blue channel for that, and then that will correct what the setting is. So it's basically like the invert setting up here, but just per channel. And then we also have the gamma setting of this. And what this is it's a curve that represents the dark point and the light point, and it's a straight line when it's set at 1.0. So if you've previous versions of Modo, you're probably familiar with the fact that we used to have to de-gamma images that we've imported in for linear workflows. Now that's all taken care of by the color management system that we've implemented in, I think, Modo 8 was when that popped up. So things can just remain at image or at gamma 1.0, but sometimes it's useful for me, I think, in grayscale images to adjust the gamma down to sort of make darker areas a little bit darker, or you can adjust it up to lighten up lighter areas. So you can kind of see how when you adjust that down, how the darker areas start get really dark, and then if you go over one, you start to really brighten up any of those darker areas and kind of almost blast out some of the brighter areas. So I don't use that very often, but it is a useful sort of image manipulation feature to adjust a texture a little bit without having to jump into Photoshop. And the swizzling option here, this is kind of like what I was talking about before with Unity assets. So if you enable Unity, or excuse me, if you enable swizzling, then you can specify specific channels that you want to go in here and apply. So if you enable the swizzling, set to channel red, then you can go up here and then you can set your, say, your Unity to the albedo, or excuse me, you want your bump might be in the red channel. I know that's incorrect, but I don't remember off the top of my head what they all were. You can go in and you can do the green, and then the green might be your Unity metallic, you know, whatever the different setting is. So if you have swizzling turned on, this changes into a little channel selector, which lets you specify from that image which channel specifically you're going to be applying as this effect. And if we disable that, this gives us an option for the alpha channel. Now the alpha channel setting is really useful, but it works best if you have a transparent image to actually illustrate what's happening. So I'm going to add one more layer in here. So image map and load image, and we're going to load in this transparent layer right here. So what the alpha channel settings do is it lets you specify what the transparency or the alpha channel of a layer does. So by default, of course, it's going to use the transparency, and it doesn't actually make the surface itself transparent. It just, when you use a transparent image such as this, you can see that it actually, it's the transparency of the layer itself, and it shows the underlying layers through this. So if I were to turn that off, you could see the underlying material now shows through underneath the transparency of that layer. Now if we go back into that, we can tell that to ignore that, and then whatever is within the image itself minus the transparency of it is what you're going to see. So in this case, this is what it looks like if you were to kill off all the transparency of it. This stuff is, you know, obviously hidden in that, but then you can, if you have an image, a regular image that you've floated or something like that, then you can disable that and use the full image and ignore the transparency of that. And then inversely, you can use the transparency of that as an alpha channel only. So this, using the alpha channel, it's basically showing up in this case as diffuse color, but then you can take that transparent color and you can see, if I were to set this to like a transparent amount and then invert that layer, then that's going to set the transparent amount, where this is going to give me a true alpha channel of what that layer was, versus if I had used the image of that set as transparency, then that's going to give me variable transparency on that. It's not very noticeable, but because the luminosity of that is fairly bright. So then if I invert that, obviously, then it makes it more obvious what's going on. So I find the alpha channel alpha only is useful if you have a transparent image and then you want to instance that image to a new layer and then set that to alpha only. Then you can set that to group mask, and then that lets you use the true transparency alpha of the layer without having to go back and save a separate alpha mask just for that other layer effect. So I find that the alpha channel option is pretty useful for, you know, lots of different cases where I'm working with transparent images. So, like I said, this is the image map layer that I've covered here. In my next video, I'm going to be going over the texture locator. But hopefully on the image map, you learned something on that. And thank you for watching.